Good day, sir. We are the Group 4 and the members are Decadet Kanama, Jeff Shepard A, Caracena Mark Joseph B, and Cabalite Joshua Q. Course Mtec 102, period semifinal TTH 10:30 to 12 p.m. Week 1, Session 1, topic Errors and Health Effects of the Radar. So, learning outcomes. At the end of the session, the student shall be able to determine the radar errors and the possible health effects of radar. What are the possible health effects of radar? Most studies conducted to date examine health effects other than cancer. They prove into physiological and thermoregulatory responses, behavioral changes and effects such as the induction of lenses, opacities, or cataracts, and adverse reproductive outcome following acute exposure to relative high levels of RF fields. There are also a number of studies that report non-thermal effects where no appreciable rise in temperature can be measured. Cancer-related studies. Many epidemiological studies have addressed possible links between exposure to RF and excess risk of cancer. However, because of differences in the design and execution of these studies, their results are difficult to interpret. A number of national and international peer review groups have concluded that there is no clear evidence of links between RF exposure and excess risk of cancer. WHO has also concluded that there is no convincing scientific evidence that exposure of RF shortens the lifespan of humans, or the RF is an inducer or promoter of cancer. However, further studies are necessary. Skin cancer. As you can see in the photo, the hand of this person has a cancer, has a skin cancer.
These are the following radar errors. 1. Heading marker alignment. 2. ABL not alignment. 3. Gyro input with error. 4. Improper tuning. 5. Improper range. 6. Blind sector. 7. Adjustment ring clutter or C clutter. 8. On bezel date input error. 9. Range and bearing discrimination. 10. Beam width distortion. 11. Side lobe echo. 12. Multiple echo. 13. Second trace echo. Heading marker alignment. A collision point could occur of the heading marker in a collision situation. When the same error occurs in both heading marker and calculation, as might occur due to a gyro compass error, the collision case will always show the collision point on the heading marker. ABL not alignment. The ABL system has a limited area of exposure or writing field, and the large pattern is divided into many writing fields exposed side by side with stage movement between each field exposure. The deviation from perfect alignment between consecutive writing fields is called stitching error. Blind sector. A sector on the radar scope in which radar echoes cannot be received because of an obstruction near the antenna. Ring clutters. Clutter is a term used for unwanted echoes in electronic systems, particularly in reference to radars. Such echoes are typically returned from ground, sea, rain, animals or insects, chaff, and atmospheric turbulences, and can cause serious performance issues with radar systems. Range discrimination. Two small targets on same bearing and slight range difference may be shown on a target. Bearing discrimination. Two small targets on same range and slight bearing difference may be shown as one target. False echoes. Beam with distortion. The finite beam width of the radar results in echoes being extended in the azimuth direction, called azimuth distortion. It is apparent that azimuth distortion will result in an enlargement of a target by approximately 1/2 beam width on either side. So total enlargement is equal to 1 beam width.
Side lobe echo. The finite beam width of the radar results in echoes being extended in azimuth direction, called azimuth distortion. It is apparent with the azimuth distortion will result in enlargement of target by approximately 1/2 beam width on the other side. So total enlargement is equal to 1 beam width. Multiple echo. Multiple echoes may occur when a strong echo is received from another ship at close range. A second or third or more echoes may be observed at radioscope at double, triple, or other multiples of the actual range by radar contact. Second trace echoes, multiple trace echoes. So our echoes received from a contact at an actual range greater than radar range settings. If an echo from distant target is received after the following pulse have been transmitted, the echo will appear on the radar scope at the correct bearing, not on a true range. The second trace echoes are unusual except under abnormal atmospheric conditions or conditions under which super-refraction is present. One of the limitations of ship radar is that may not be able to detect an object due to its size, proximity to the surface, or when an object is poor radar target because of its construction or design. For example, military ships are designed so that the radar waves do not reflect back to the receiving unit of radar scanner. This also happens with wooden fishing boats as they have poor radar reflective surface. Small unit boats engaged in fishing are also difficult to sight visually at night. Sometimes they may not be seen during daytime from the bridge due to height of the angle of viewing direction or reflection of the sea surface. So when navigating in proximity of such vessels or there are no operating areas, it is good practice to post an alert lookout with a walkie-talkie or walkie-talkie on a forecastle deck. In the following picture, seaweed is giving very good radar returns due to highly reflected surface. It had covered the whole sea surface during low water, but because it was the ship's first call to port area, which was not well surveyed. My first thought was that there may be an error in the charts, that we altered course to stay well clear. We started approaching only after getting positive confirmation by all positive means that it was safe to do so. There was ample water with sufficient depth. It is always better to be safe than sorry. It was also concerned if the seaweed, because of being so densely packed, could in any way foul the bow thruster.